the two graphs that we had in this last unit to make sure that you knew what they were. The first graph was just, okay, let's try the pen. First graph was just what we call a phase diagram. Okay, in this area here it's solid, and this is liquid, and this is gas. This point right here was a triple point, meaning solid, liquid, and gas all exist at the same point. This right here is known as the critical point. Past that point, it's gas. So, past that point, it's gas. If I come across at 1 atmosphere, and I hit this line, this is the boiling point line right here. That would be what's called normal boiling point. When I hit the liquid to gas, sorry, that was the freezing point. This is the boiling point. This would be the normal boiling point. So wherever 1 atmosphere is coming across, that's known as normal. Okay? That's one graph. The other graph that we sort of need to talk about or go back over is the one that looks like this. This one also tells me solid, liquid, and gas. In this section right here, I'm heating a solid. Here, I'm melting a solid, or freezing, depending on what way I'm going. Here, I'm heating a liquid. And here, I'm boiling or condensing a liquid, and here I'm a gas. I'm heating a gas. So anytime that it has a slope, I'm heating. Okay? Anytime I have a slope, I'm using that equation, Q equals mCp delta T. And Cp is my specific heat. Okay? So if I say I'm going from -10 to +10, I'm going to have 3 Qs. Remember this one, I'm not going to have a change in temperature, so if I tried to use this equation on the flat area, I would get 0 every time. So instead for this area right here, we just go Q is equal to delta H of fusion times the mass. For here it would be delta Q is equal to delta H of vaporization times the mass. So we actually have different Qs. So I would take and I would go from, let me change color, I would go from -10 to a +10. I would use this Q using the specific heat for ice. And then I would use Q, so that would be Q1, Q2 would be here on the flat area, and I would use delta H of fusion times mass. And going from here to here would be 0 to 10. I would use Q3, which I'd go back to the mCp delta T, but I would use the Cp for liquid water. And that would be Q3. And then I just add them up. So we've used the Qs when we heated stuff up, when we did the metals. I know it's been a while because it's been a long unit. Okay, all you have to do is add them up. So basically 2 equations, this one and this one. Remember what's happening at each. I'm heating the solid, I'm melting the solid, heating the liquid, heating the liquid, vaporizing liquid, heating the gas. So they're both telling me about the phases. On this one, you would be given an atmosphere and you'd be given a temperature, and you've got to come across and tell me what's happening. Okay? All right, the other 2 things that we talked about are molarity. And remember on molarity, I said remember that right here is a lake. So you could remember It's moles over liters. Okay, the other one that we use is molality. And I told you, remember, that's fat, and that's moles over kilograms. Now, some of them you have to go back to your mole map because you'll be given grams. So remember, when you're given grams, you have to set it up so you have 1 mole on the top, and you have to add up your grams and put it on the bottom to get moles first. To go from milliliters to liters, same thing. You put your milliliters on the top. You'll put 1,000 milliliters on the bottom, 1 liter on the top, and get liters. Kilograms works the same way. If you have grams, there's 1,000 grams in 1 kilogram. The other equation that we worked with was with our ice cream, which was delta T equals K times M times I, right? And depending on if we were working with freezing point or boiling point, K of freezing point was 1.86 degrees Celsius per molal. K of boiling point was 0.52 degrees Celsius per molal. And then I is how many parts it would break into. Okay? So those are the basics of what's on the test. Do you have any questions we can go over? Yes?
So you said that if it was past the line, then it was gas?
On,
The graph.
yep.
So like,
So
in that
anything this way, and anything, yeah, basically anything all over here is going to be gas. Because it doesn't matter how much pressure I put on it, if the temperature is so high that the gases can't settle down enough to be a liquid, they're going to always be gas.
So that red middle, that would be liquid?
Right here would be a gas.
Oh, so underneath that's gas too.
Yeah, underneath this line is gas. Anything past this point is gas. The Y, inside the Y is liquid, and close to the Y-axis is solid. Yes? This is the phase diagram graph, and this is the heating graph, or heating curve. Any other questions you'd like to go over real fast? So these are the 2 equations you need for the heating curve. Okay, and then coming back over here, we've got 2 equations we need to know: molarity and molality. And then freezing point depression is right here. Let's see it. And you'll need to know those 2 Ks. Double check real quick. I don't have the multiple choice up, but that is something written. Anything else you'd like to go over? How was your sub?
Can we do retakes on this?
Yes. Just remember, on the flat, all you have to do is times the heat of fusion times the mass, or the heat of vaporization times the mass. And anytime there's an angle, that means I'm heating one of the phases, solid, liquid, or gas. And solid's always closest to the y-axis. And you should be able to read a temperature off. This would be the temperature of melting. This would be the temperature of boiling. Okay. Any other questions? Okay, if no more questions, go grab your cubies to make your cubicle around you, and then grab your computer, get it up and running, and then all your other crap up here, no electronics on your body at all, please. Batteries and smartwatches. I will get you a periodic table. You can have a scratch piece of paper if you'd like now. I have a scratch piece of paper back there if you don't want to use your own. Please make sure you're uploading your homework and your notes and stuff. I'm not getting a lot